Alright, so here's a question. You can see money, you can see percentages, so you might be triggered into thinking maybe compound interest, maybe finance solver, but for this one it's actually sequences and series. So let's just see how we can unpack that and home in on the fact that it is sequences and series. So you've got these two situations, you've got Anne and Greg. Now, even before you look at parts A, B and C, it's always a nice idea just to put down what's going on. Here's Anne, here's Greg. Anne is paid 1,000 in January 2020, so January 20. I'm going to put February 20 because it looks like they're paid each month. Here's March 20 and here's April 20. Okay, so we're just going to do this just to get a feel for what's going on. So Anne's paid 1,000 and these are all dollar amounts. Okay, so we'll just put that to the side, dollar amounts. Increasing by $50. So there's an increase of 50. So 1,050. Okay, so this is pretty helpful, right? Because if it's plus 50, this is something to do with arithmetic. And now look at Greg. Greg's paid 600 here, and that increases by 10%. So we're not. It's tempting to do this, right? Plus 10%, but we've got to be super careful there because think about what it means if we increase by 10%. We've got 110% of the previous amount. So we've got all of it, 100 plus an extra 10%. So this is actually times by 1.10 to increase by 10%. So this is what's happening over here. So can you see that actually this is arithmetic and this is geometric. And what I'm going to put down here, this is u of n, is the nth term of a geometric. It's u1 times by r to the n minus 1. Over here, we've got u of n equals u1 plus n minus 1 into d. And we've got the sum here is u1 r to the n minus 1 over r minus 1, straight from the formula book. And the sum here is n over 2 2u1 plus n minus 1 d. Okay, so look, we haven't even started reading a question, but we do have a good feel for maybe what's happening here, and spending time doing that is definitely a good thing, so you don't go down the wrong route of maybe finance solver or maybe compound interest. We know that we're dealing with arithmetics or geometrics, and we're going to be using the formulas that I've just highlighted. Okay, so let's go now and answer the actual questions. We want to know Greg's monthly salary for February 21. Okay, so now we're just going to go back up here. This is going to be the first term, the second term, the third term, and the fourth term. Now we've got to think ahead. This is actually going up to February 2021. Okay, so basically, can you think that December 20 will be the 12th month, January 21 will be the 13th, and February 21 will be the 14th. So we've basically got n equals to 14. And if we use then the formula, which is this one here, because this is Greg, we can just bring that formula right down there and we can just replace. So we want u, the actual amount that he gets paid, u of 14, and that's u1, you can see it's the 600 to start with, times by r is the 1.10 to the power of n minus 1 there. So that's equal to 600 times by 1.10 to the power of 13. Now I'm just going to do this on my TI-Nspire. There's nothing too fancy needed here. You're just going to type this in exactly as you see it. So I'm just doing it now. I'm not going to show you because I don't think you need it. Insert calculator. I'll just type in exactly as this. 600 times 1.1 to the power of 13. Now I've got 2,071.3636. So I'm going to just leave that to the nearest second decimal place because that seems to be dollars and cash. Alright, let's just put in an extra page. And now we're going to answer part B. Find the total amount received by Anne in the first year of her contract. Okay, so here's Anne. Remember, Anne's on an arithmetic. and we want the total received in the first year. So that's 12 months. Think about what U of 1 is here. Think about what D is. And we want 12 months. Okay, so let's go ahead and just go over the page. And we think we know what we're doing here. B. So we want the total, the sum, and that's going to be n over 2, 2u1 plus n minus 1 times by d. Now we'll list everything out. We've got n is 12 months. We've got u of 1 is the starting salary, 1,000. And we've got d is the common difference, is 50. So let's go ahead and work that out. S of 12 equals 12 over 2, open brackets, 2 times by u1 plus n minus 1 times by d. Again, I'm just going to go straight to my calculator, type all that in. It is 6, that's 12 over 2, right, times by, and make sure you get the open brackets in there. Oops, there we go, got it. 2,000 plus 11 times 50. Okay, so that's 15300. So I've got the total salary that she receives is 15,300. Now the last question is something that we will need to have a little look at on the not on the finance solver, sorry, on the calculator. There's a sequence series, not to do with finance solver. C, find the month and year in which the total amount received from Greg's contract first exceeds the total amount received from Anne's contract. So I'm going to go ahead and set that up as some kind of an equation. So what we're looking for here is the sum for Greg is greater than the sum from Anne. Okay, so just a little bit of basic notation. Now let's think about the summation formula for Greg. Well, the summation formula for Greg is based on this one, because it's geometric, and the summation formula for Anne is based on this one, so let's go ahead and just fill in the gaps here. So the Greg summation is this. Remember, u of 1 for Greg was the 600 times by 1.1 to the n minus 1 over 1.1 minus 1. And for Anne, S of n equals n over 2. 2 times u1, I'm going to put that as 2,000, plus n minus 1 times by d. And the d was, I think, 50. You just go check all that. Equals by 50, yeah. Okay, so here we've got two equations, and we want to know when is Greg's amount going to be bigger than Anne's amount. So typically we just solve this as an equation and then think about, do we need a year more or a year less than the final solution? So we want to solve the following, and we can do this on nsolve, or we could graph. So I'm going to solve when is Greg's I'm going to just work that out because I think I can, equal to Alright, now remember, this is going to go into nsolve. I'm going to put that in brackets. Now remember, we need to put comma after the end of the equation and the variable n that we're going to solve for. Alright, so that's quite a lot to type in, but it's going to be hard to work out any other way. So you can have a little go at that. We can also use tables of values for this. We can use a whole variety of methods.